In order to get an engine running, it first needs to be rotated at sufficient speed. Thus, it gets the fuel pumped up to the cylinders and ignited and enables the engine to run on its own power. Cranking the engine simply means turning the engine's crankshaft that rotates the engine to power itself. There are several common causes of engine vibration in a car, and they all result in shaking and noises that can be quite alarming. However, if you know what some of the most frequent causes of engine vibration are, you can not only avoid too much stress and worry. Your motor mounts are what keep your engine attached to your car. If your motor mounts are broken or have become disconnected from your engine, this can be the cause of your car shaking. If the shaking decreases when you put your car into neutral, this could indicate that it is the motor mounts. One of the most common symptoms associated with worn engine mounts are impact noises coming from the engine bay. Worn, damaged, or broken motor mounts can cause clunking, banging, and other impact-type sounds as a result of the weight of the engine shifting excessively to the point of contact. If the rubber or vibration-dampening parts of the motor mount wear out or break, it will significantly reduce the mount's ability to absorb engine vibrations. Undamped engine vibrations will cause the entire vehicle to vibrate, which may make the cabin uncomfortable for the passengers. Time and thousands of stops and starts take their toll on the rubber holding the metal of the motor mounts together. The rubber can crack, become spongy, or just plain fall apart. Liquids leaking onto the mount itself will accelerate this process. Oil, power steering fluid, transmission fluid, or any other leaking liquid falling down on the engine mount will speed its demise. Follow the steps below for some handy tips for replacing engine mounts. Inspecting and replacing worn or broken engine and transmission mounts will help the rubber meet the load. Step 1. Check for clearance against the firewall before attempting to raise the engine. Tearing radiator hoses, crimping AC lines, or cracking distributor caps should be avoided. Secure engine on jack with blocks of wood. Step 2. Secure the engine on a jack with various blocks of wood. Never jack an engine directly by the oil pan. The pan will bend and rupture. Loosen engine from mount bolts. Step 3. Loosen the engine from the mount bolts. Sometimes a long extension and universal joint is the way to go. Next, crawl under the vehicle and loosen the mount to frame bolts. Jack up the engine a little at a time and remove the motor mount. Step 4. Compare the old and new motor mounts. Transfer any heat or drip shields to the new mount. Step 5. Thread in the mount to frame bolts before lowering the engine. This will simplify mount alignment. Step 6. Lower the engine and fully tighten all bolts. Worn-out spark plugs. In many vehicles, a common cause of engine vibration is worn-out or faulty spark plugs. Worn-out or dirty spark plugs will cause the car's engine to misfire or not properly fire on each and every cylinder. When this occurs, it is commonly referred to as the engine missing or not firing on all cylinders. This can usually be corrected by installing new spark plugs or correcting other spark or compression-related issues. Increase fuel efficiency. If your engine is powered by worn-out spark plugs, it will not run as efficiently as intended. When you replace these faulty plugs with a set of fresh plugs, your engine will run smoothly and require less effort to keep the combustion process going. This will translate into increased fuel efficiency over the long run. Reduce the risk of damage to your engine and other components. Faulty spark plugs can cause misfires, poor fuel economy, lackluster acceleration, and other issues with your ignition system. Left unaddressed, malfunctioning plugs can also cause damage to other components such as your catalytic converter, so it's vital that you immediately replace bad plugs. Types of spark plugs: 1 copper, 2 platinum, 3 double platinum, 4 iridium. The best spark plugs on the market boast an iridium construction. Iridium spark plugs give you even better gas mileage, performance, reliability, and longevity than double platinum plugs. Due to the advanced material and innovative technology integrated into iridium spark plugs, these plugs are priced higher than copper and platinum options. Iridium spark plugs are perfect to use on high-performance engines. When do I need to change my spark plugs? Most manufacturers these days will install extended life spark plugs at the factory. They're only marginally more expensive than a standard plug, and it sounds really good to the consumer. Extended life spark plugs are usually rated for a lifespan of around 100,000 miles. As these plugs approach the end of their life, the gap between the two leads begins to widen, which leads to reduced efficiency and the possibility of misfiring. If your plug corrodes to the point where it breaks, it could do serious damage to the interior of your engine cylinder, which leads to an extremely expensive repair to get it fixed. Cheaper spark plugs may cost around $2 to $3, while premium plugs with precious metals may cost as much as $20 to $25 apiece. Whether you do a complete tune-up or only change the spark plugs, spark plug wires, also known as ignition cables, should always be checked first. This is necessary due to the aging of the spark plug wires from exposure to extreme temperatures, hot and cold, engine chemicals, oil, grease, coolant, etc., and electrical stresses. Common signs of failing spark plug wires include a decrease in power, acceleration, and fuel efficiency. In addition, the engine light coming on or visible damage to the cables can be signs of a failing wire. Be sure to first check spark plug wires for visual damage. Look for any signs of melting or cracking. The following situations call for immediate replacement of spark plug wires. Constant wear and tear caused by engine vibration can loosen the electrical connection at the spark plug. This causes an increase in the voltage required to fire the spark plug, which could damage the ignition coil as well as the spark plug wires. Engine heat can burn wire insulation and boots. When spark plug wires rub against engine parts, particularly sharp edges, it causes cuts and breaks in the insulation. Once this happens, voltage can jump to ground instead of reaching the spark plug.